Alright, so let's solve May 2021 past paper. It's a blend of, very complex concepts and some easy ones as well. So let's solve this one. The elements of the universal set U are constants from 1 till 10. Consider two subsets of U. So basically, whenever we see the word subset, it means small branches of main set. Set A contains the multiples of 2 and set B contains the multiples of 3. So if set A contains multiples of 2 and set B contains multiples of 3, we know that the intersection region should be consisting of numbers that are present at every place, alright? Like at both places. So I can definitely say, as far as multiples of 2 is concerned, so they are going to be 8, and the multiples of 3 are going to include 9. But there's one number that's also a multiple of 2 and a multiple of 3. Out of the options that we have, 8 and 9 are eliminated. What about 6? 6 is a number that can be present between both. And 5 is a part of the universal set, but it's not a part of any of the two sets. Alright? So that's how we are going to categorize our numbers. Make sense?
Yeah.
Alright. Describe the region A intersection B complementary. So wherever it says B complementary, it means everything except for B. Right? So first things first, let's start with that. Everything except for B means this one, which is A is definitely a part of it. Alright? But here comes the confusing part. We have in front of us intersection. Alright? And whenever we're talking about intersection, so first things first, let's also highlight A. A is highlighted completely. But here comes the tricky part. Whenever it says intersection, I always tell my students that intersection is supposed to consist of the overlapping region. Alright? The region that is essentially overlapped and present from both sides. So, realistically speaking, A is not going to be considered the additional region. And this part, this region, is also not going to be considered. Why? Because it is the overlapping region. So at the end of the day, what options are you left with? You are left with only the option that is present inside of A. So that is essentially, what do you have essentially? You have the multiples of 2 as your final answer. Alright? So we can say, if it says describe the region A intersection B complementary in context, so in context means that we have to describe it in a word form. So we'll say that this region consists of multiples of 2 that are not multiples of 3. This is very important. Most students would have done this part and they would have gotten the right answers as well. But this part is what they wouldn't have done. Why? Because this helps us focus on a very important aspect of it. We don't consider 6, alright? This is a proof of the fact that in order to describe this in context, this is going to be our best approach. Multiples of 2 that are not multiples of 3. I hope this makes complete sense.
Yeah, it does.
That's great. Whenever you see sets and Venn diagrams, always expect the question of either identification of a region or probability next to it. That's like almost um, inevitable because these concepts are somewhat interlinked. Two numbers are selected at random from U. Determine the probability that they are both elements of A union B complementary. Okay. A intersection B complementary. A intersection B complementary consists of how many numbers in total? 1, 2, 3, 4. 10, 2, 4, 8. So there are a total of 4 numbers present in this region. So we know that the first probability is going to be a 4 over 10. It says two numbers. So the probability of the first number is going to be 4 out of 10 because there are a total of 10 numbers, and out of that from the desired regions we have 4. And likewise the probability of the second number would be 3 over 9. Why 3 over 9? Have a look. If we were to, for instance, select a number random, let's say we selected 8, that was already taken out. How many numbers are we left with as far as the numerator is concerned? 1, 2, 3. And what's the total amount of numbers that we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is what we call the replacement type of questions in probability. So the probability of second number would be 3 by 9. And of course, in this case, both of the probabilities are going to multiply with each other. So this leaves us with an answer of 12 over 90. This is how we're supposed to solve this question, right?
Yeah.
So this can also be written as 6 over 45 or 2 over 50. All of the answers are correct. Two numbers are selected at random from you. Calculate the probability that only one is an element of A intersection B complement. Okay, this is a little bit tricky, so have a look. Look, it says two numbers are selected. Calculate that only one is an element, which means that there are two possibilities, right? If I select, so maybe uh, this is an element and this is not an element, or this is not an element and this is an element, right? So there would be two types of possibilities. That maybe you select a random first, which is an element, random number, and the second time it's not an element anymore. Or maybe another probability is that the first time you select a number that is already an element of A intersection B complementary, and the second time that you select a number that's not an element of A intersection B complementary. So, how do we solve a question that looks like this? We know if we were to have a look at this case, let's say the first attempt that we had, we picked out an element. So what is that? We know that the chances are 4 by 10 as we calculated in the previous part of us getting our element in our desired region. This is our desired region. The region consisting of the numbers 2, 4, 6, 2, 4, 8, and 10. Alright. Now, let's say this is our first probability and this is our second probability. In our first probability, we get a number on our first term, and the probability of us not getting a number would be 6 over 9. How? One value is going to decrease from the denominator, and there were a total of 6 numbers left. There were a total of 6 numbers left. So this becomes 4 over 10 multiplied by 6 over 9. And just like that, the probability of us getting a number, not getting a number at the first time was 6 over 10. Why? Because 4 over 10 was the probability of us getting a number. So not getting a number would be 1 minus 4 over 10, which is 6 over 10. That is supposed to be multiplied by the total numbers that is already present there, 4, and one value is going to decrease from the denominator. So we're supposed to solve this. 4 times 6 becomes 24, and 10 times 9 becomes 9. 6 times 4 becomes 24, and 10 times 9 becomes 90. And then what will we do? We simply add both of these values together. So we get 24 over 90 plus 24 over 90, that is equivalent to 48 divided by 90. Does that make sense, or do you need some more?
I got it.
That's great. Write it down and tell me once you're done. So question number 2 says, the table below shows an example of a complete addition grid. So this is the addition grid basically. 3 plus 4 equals 7, 3 plus 5 equals 8, 10 plus 4 equals 14, 10 plus 5 equals 15. Alright. So it says under root 20 plus under root of 5. Now this is something that can be solved using a calculator as well, but I mean I would personally prefer that the calculator is not used. Under root 20 plus under root 5, let me break it down in a more easier way. Why? Because there is a underlying concept in it. Under root 20 can also be written as under root 4 multiplied by under root 5. Under root 4 can be written as 2, and under root 5 remains as it is. So 2 root 5 plus 1 root 5 remains as it is. Alright? 2 root 5 plus 1 root 5 remains as it is. So we get a total answer of 3 root 5. Alright?
Yep.
And just like that, we have under root 45 plus under root of 5. So let's do it. So yeah, under root of 45 plus um, under root of 5. Under root of 45 can be written as under root of 9 multiplied by under root of 5 plus under root of 5. Under root of 9 is 3 root 5 plus root 5. So this becomes 4 root 5. So we have our two answers, 3 root 5 and 4 root 5. If we were to consider this value of x, We know that under root of 20 plus x equals under root of 5, to under root of 5 plus x equals under root of 5. So x equals under root of 5 minus 2 under root of 5, and I think that answer would be minus under root of 5. I think so. Yep, that makes some sense. Is this part clear to you?
Yeah.
Minus under root of 5. So this is how we were supposed to solve this question. Now you see, such questions are not part of the IGCSE syllabus. Such questions are only present in the IB uh, exam style. Now, this is basically the surge concept being tested, right? It's not exactly rocket science, but students still don't get it, most of them. So that's how it works. All right, then we have the multiplication grid. So we're supposed to solve these values directly. The first example is given as 7 over 2a multiplied by 2b. 7 over 2a multiplied by 2b. This should be equivalent to 2's being cancelled with each other and our answer being 7ab. So here you go, 7ab. Then be careful. Let's consider this value as x for now. Alright. Um, I know that when 7 over 2a is multiplied by x, this is equivalent to 14a square b raised to the power of negative 2. Further solving it, x is equivalent to, let me write it like this. Let's take 2 to the other side of the equation. So we get 7a multiplied by x equals 28a square b raised to the power of negative 2. And x can be written as 28a square b raised to the power of negative 2 divided by 7a. So what answer does this leave us with? When 28 is divided by 7, we get a value of 4. When a square is divided by a, so we get a value of, um, am I doing it correctly? I think so, yeah. Yeah. So in this case, we get the value of a, and b remains as it is. B remains raised to the power of negative 2. So that was for the value of 4ab raised to the power of negative 2. This is what we were supposed to basically find out. Alright,
Yeah.
so the answer is 4ab raised to the power of negative 2. Now, here comes the trick. You see, this region, let me label this as y, multiplied by this region is going to give us the answer of this. So let's find the region of y. Y multiplied by 4ab raised to the power of negative 2 equals 12a5 a raised to the power of 5 b raised to the power of negative 1. y equals 12a raised to the power of 5 b raised to the power of negative 1 divided by 4a b raised to the power of negative 2, because on the other side of the equation it divides. 12 over 4 becomes 3. A raised to the power of 5 divided by a, simple a, gives us the value of a raised to the power of 4. B raised to the power of negative 1 divided by b raised to the power of negative 2 gives us the answer of b raised to the power of, mm, well, here we go. Because we have a division sign in between. So what happens to the values? Minus 1 minus minus 2. Minus minus becomes plus. So we get minus 1 plus 2, which becomes b. Simple b. So we get 3a raised to the power of 4b as our answer. Alright. So I can write this as 3a raised to the power of 4b. And then 3a raised to the power of 4b multiplies by 2b to find the value of, let's say, whatever it is. Let's not worry about what value it is. Let's solve it. 3a raised to the power of 4b multiplied by 2b. 3 times 2 gives us the value of positive 6. A raised to the power of 4 remains as it is, and b multiplied by b becomes b raised to the power of 2. So you get an answer of 6a raised to the power of 4b squared. 6a raised to the power of 4b squared. And that's how we are going to solve question number 2. I think it was only this part. Yeah. It was a difficult question. It's not a typical SERDS question, which is often, not considered by most students. But yeah, I hope this part is clear.
Yeah, it is.
That's good. That's good. Let's try to finish this paper today completely and solve other questions. In the graph below, function f of x equals 2s plus 4 and g of x equals x minus 1 whole square minus 2 at points a and b. Um, okay, this is somewhat a part of coordinate geometry, but it's not too difficult since uh, I gave you a worksheet and you solved questions of quadratic simultaneous. So this is what we call a quadratic simultaneous, when there is basically one linear and uh, one quadratic curve. So basically one parabola. All right. So we get the function f of x equals 2x plus 4. It intersects g of x at this point. So whenever it says intersects, you should always equate both of the functions with each other. Why? Because if it intersects, it's supposed to have a point of intersection. And at that point of intersection, the values of x and y are going to be numerically equal to each other. Let's see what the question has to say. Show that when the two graphs intersect, x squared minus 4x minus 5 equals to 0. Okay, let's show it. How do you show it? It says intersects, which means we have to equate both of them. So I will write x minus 1 whole squared minus 2 equals 2x plus 4. Because f of x can be considered as y, g of x can also be considered as y. Let me expand this bracket. X minus 1 multiplied by x minus 1. X into x becomes x squared. X multiplied by negative 1 becomes negative 1x. Negative 1 multiplied by x becomes negative 1x. And negative 1 multiplied by negative 1 becomes positive 1. So we get x squared minus 2x plus 1 minus 2 equals. 2x plus 4. Let's take all the terms to the left side of the equation to make sure that we have only 0 on the right. X squared minus 2x plus 1 minus 2 minus 2x minus 4 equals to 0. So the x squared terms remains as it is. So we have x squared minus 2x becomes minus 4x. 1 minus 2 minus 4. 1 minus 2 minus 4. 1 minus 2 is basically minus 1, and minus 1 minus 4 is minus 5, and the entirety of this is equivalent to 0. This is exactly, this is exactly what we were supposed to show. Alright, using the idea and the concept of line of intersection. I hope this makes sense.
Yeah.
Alright, that's good. Usually this question is solved once quadratic coordinate geometry is also complete, but it's not exactly rocket science. I mean, it's most of it is pretty similar and easy. Hence, find the coordinates x, y of points A and B. Hmm. Whenever it says hence, it means use the previous part to answer it. So we have the equation x squared minus 4x minus 5. Alright? We have to use this previous part in order to solve it. And find the coordinates x comma y on the points a, b. So let's solve the value x squared minus 4x minus 5. Let's find the factors of 5 first. Should we, I think we can solve it using middle term breaking. So factors of 5 include 5 times 1. So we have to manipulate 5 times 1. So we get x squared minus 5x plus 1x minus 5. Take x as common, and within the bracket you have x minus 5. Take plus 1 as common, and within the bracket you have x minus 5 again. So you have two brackets, x minus 5 and x plus 1. The value of x is either 5 or negative 1, because we take the negative value of whatever is present inside. It's either 5 or negative 1. Now we have to substitute these two values of x into the linear equation of 2x plus 4. So basically, when the x value is 5, you get 2 multiplied by 5 plus 4. 2 multiplied by 5 is basically 10, plus 4 gives us the answer of 14. So when x equals 5, y equals 14. And when x equals negative 1, you get 2 multiplied by negative 1 plus 4 minus 2 plus 4. The value of y is going to become positive 2. So the coordinates that you have are minus 1, comma 2, 5, comma 14. Now here comes the tricky part. How to identify which one is which? So, I mean, it's not that tricky. It's pretty easy to understand. Have a look. We have x equals negative 1 here. So we can, if you were to look at the entire Cartesian system of coordinates, we can see that the value of x is negative at this region only. So A is going to be the coordinate minus 1 comma 2. B is going to be the coordinate 5 comma 14. So this was also like a quadratic equation type of a question, right? So because we had to find using the quadratic equation.
Yeah.
All right. So do that so that we can move forward. Then the last part says determine the distance AB. All right, this part is basically coordinate geometry, completely coordinate geometry. So this is going to be labeled as x1, y1, and this is going to be labeled as x2, y2. You don't have to solve this. I'm just solving it for the uh, audience in itself. So the formula that is used is under root x2 minus x1 whole square plus y2 minus y1 whole square. This formula is general, it's always used. So, and this is also going to be given. So we can write this as minus 1 minus 5 whole square plus 2 minus 14 whole square. This becomes under root of 6 squared plus minus 12 whole squared. So that becomes under root of 180, which is equivalent to under root of 30 multiplied by under root of 5. And under root of 30 can be written as 6. So we get an answer of simply 6 root 5. Alright, let's move on to the next question. Some creators make videos that are very popular and viewed by many people on video sharing platforms. Advertisers pay the creators to have their advertisement included in the video. Alright, sure. Thank you. Right. Okay. Most of it is unnecessary information. I tell my students whenever we're solving questions like these, where there is a lot of information given, excessive, instead of reading the entire part, just focus on numericals or you know uh, digits or numbers that have been given. Except for that, don't worry about that. So this is what we have to focus on. Here is an example. For every 1,000 views, creators earns $4 per 1,000 views. A creator uploaded a video and received 623,775 views. The pie chart shows the views of the advertisements. Determine the number of full views. Now, automatically, we know that 20% of the total views are full views. So, I can write this as 20 over 100 multiplied by 623,775. So if I was to solve it on a calculator, I would get 124,755. All right, let's move forward. Okay, the creator pays a fee of $150 to the video sharing platform. Calculate the profit that was made. So basically, he had 124,000 full views, right? At least 755 is not going to be considered as it is not as basically the views are per thousand. So he had a total of $124,000, 124,000 views. So I can say that for every 1,000 views he earns $4. So I can write this as 124 multiplied by 4. This becomes $496. But he also pays a fee of 150 to the video sharing platform. So we subtract 150 from it. 496 minus 150, we would get an answer of 346 dollars. I hope this part makes sense because this was very easy to understand. 124,000, and for every thousand full views, we get $4, right?
Yeah.
Okay. All right. So it says for this video, find the minimum number of views required to make a profit of $500. Through this video, no, through the previous video, I think. No, no. Okay, all right. So have a look. Basically, if we were to look at this question in much more detail, it says that he should be able to make a profit of $500. And that profit is independent of the fee that he has paid of 150. So basically, what it says is that the total amount that he should at least earn is at least $650. So total earnings or total amount needed to earn should be 500 plus 150. 500 is the profit he needs to make. 150 is the amount that he's supposed to give. So he's first supposed to earn that amount of money. So that's a total of $650. Okay. Now, for every um, $650, $650, he is going to be given $4 per thousand view. $4 per thousand views. So if we were to divide them both together, we would get an answer of 162.5 views, right? Or like this value is supposed to be multiplied by 1,000, of course. So somewhere around, if we were to use this to multiply 1,000, so we would get, or let's take the larger ended number because we were supposed to round it off. So this becomes 163. So this becomes 163,000. So 163,000 full views will be needed. Alright. And we know that the total video views are required since full views are the only ones that are considered. So if we were to divide this value of 163,000 by 20 over 100, or basically 0.2, 163,000 divided by 0.2, this would give us an answer of 815,000 views. That is how we were supposed to solve this part. Alright, then it says, here is a snow cone. It basically is a mixture of cone and a sphere of ice. Alright, we know this. Here the sphere of ice has melted. The melted part which is going to be considered as liquid because it has its own volume. Alright, show that R equals 2.8 centimeters, correct to three significant things. All right. Hmm. Let me draw this diagram in a better way. So this is basically 150 degrees, all right? And this is 5.4, this is R, and this is R. Now, since it is not a right angle triangle, it's a non-right triangle, and a pair of angle and side is given. A pair of angle and side is given. I know that this angle can be considered as 15 degrees as well, because their opposing sides are numerically equivalent to each other. So since a pair of angle and sides is given, in that case, I always use the sine rule. I always use the sine rule. So if you were to use the sine rule, what answer would we get? Very easy. If we were to use the sine rule, we would get r over sine of 15 equals 5.4 divided by sine of 150. R equals sine of 15 multiplied by 5.4 divided by sine of 150. Can you put it on your calculator and tell me what answer do you get?
9.
2.79. So I think that is going to be rounded off to 2.8. So yeah, that is the correct answer. Very well done. There could have been like 3 to 4 methods of solving this. One method could have also been that that the student could have divided this into two separate triangles that looks like this, 90 degrees. Since the entirety of that angle was 150 degrees, this is going to be of 75, a half of it. And a student could have used the ratios as well for that. That would have been fine as well. 5 part B. It says find the value of h, which is the height. All right. Okay. So this is the diameter of 5.72. Was is the volume given? Uh, volume hasn't been given. All right. How to solve for this part? Wait a second. In order to find the value of height, okay, this is confusing. I think I'm missing out on some piece of information that should have been given. Or maybe it's not present in the question. No. Because they should have given something, some value related to. Okay, the radius is 2.8. And alright, I know what we have to do. Since we know that the radius is supposed to be uh, 2.8, I can apply the formula. The formula of what? The formula of volume of sphere. Volume of sphere. The volume of sphere is given by the formula 4 over 3 pi r cube. And that is essentially 4 over 3 multiplied by pi multiplied by the radius of 2.8 whole cube. So if you were to solve it, 4 over 3 multiplied by pi multiplied by 2.8 whole cube. That would give us an answer of 91.95 centimeter cube. So that's the first part. Then I know that there is a volume of basically um, the cone, volume of the cone in itself. So volume of sphere is 91.95, 91.95. These formula will be given to you, so you don't have to worry. Volume of cone. This is equivalent to 1 over 3 pi r square h. So that becomes 1 over 3 multiplied by pi multiplied by r in this case, which is 2.86. 5.72 will be divided by 2. So that becomes 2.86 multiplied by h. Now, the volume of sphere, basically the one that I had calculated by mistake, is basically the entire volume of this entire cone. So, volume of entire value is 91.95. So, 91.95 should be equivalent to 1 over 3 multiplied by pi multiplied by 2.86 whole squared multiplied by h. And now we have to make h the subject of the equation. So we get 91.95 multiplied by 3 divided by pi multiplied by 2.86 whole squared. And this entirety of this is going to be equivalent to h. So if we were to solve this question, in order to find the value of height, I am getting an answer of h equals to 10.73. H equals 10.73. So now let me explain it in more detail. Basically, both of the volume formula are going to be given to you in the exam. You have to make sure that first things first, uh, let me find the volume of this entire cone. This thing represents to me the volume of the melted ice. So this cone consists of the cone and the sphere, of course. So the entirety of this, first you have to find that volume, and then you have to find the volume of the cone, which is basically inherently left. So that's given by its own specific formula of 1 over 3 pi r square h. So when you apply both of these formula, be very careful about the radius. Initially the radius was entirety was 5.6, 2.8 initially. Then we were supposed to divide the radius into 2 as well to get divide the diameter by 2 to get the radius. 5.72 was divided by 2 to get 2.86. So that's applied for the volume of cone. Does that make sense?
Yeah.
That's great. Question number 6. This is not in your syllabus anymore. So you can forget about it. In this question, you will predict the reaction times of sprinters based on previously acquired data and their sleep pattern. All right. So we can see I already solved a few answers from before, just like from the previous batch. So write down the mode and the median reaction times. So mode is basically the most repeated value. Most repeated value. So looking at this graph, we can see that the most repeated value is going to be, all right, no worries. So mode is basically the most repeated value, which is going to be of 0.78 seconds. Why? Because it is of the highest frequency. The most number of sprinters took a reaction time of 0.78 seconds. So we'll write 0.78. Median. Okay, how do you calculate the median? The median is calculated by, have a look. There were a total of 20 sprinters, right? If we were to divide 20 by 2, we would get an answer of 10. We would get an answer of 10. If we were to, you know, find that what was the value of the 10th sprinter, like what was the value of the reaction time in seconds for the 10th sprinter, how do we do it? That's pretty easy as well. 4 plus 3, that is going to become 7. All right, 4 plus 3 becomes 7, and 7 plus 5 becomes 12. Now you see, this is the maximum part up till where the 10th value can lie, this region. So the 10th value essentially lies in this region. Whenever we have a graph like this, we find the median in this way. We see that where does a specific value lie, right? So if we were to add them all cumulatively, 4 plus 3 plus 5, that becomes 12, and the 10th region lies here. So we will say that the median number of sprinters is going to be 0.77. All right, that's how it is going to work. After that, question 7 part B, show that the mean of reaction time is 0.7 as well for the group of sprint. How do we calculate mean using a table? This is a very important thing. The total number of sprinters was basically 20, right? So what I do is that I make one big denominator and make 20 its denominator. One big fraction and make 20 its denominator. That was one big value. Okay. This is basically what we call the frequency, and this is what we call the value, for instance. All right. So initially what we do is that we were supposed to multiply the frequency with the value in each case. So 0.75 is multiplied by 4, 0.76 is multiplied by 3, 0.77 is multiplied by 5, 0.78 is multiplied by 6, and the good part about statistics is that each and every question is solved in the same way. All right, each and every question is done in the exact same method. So the method does not change. That's why I don't make it, I don't solve concepts of statistics. 0.79 remains as it is because it's being multiplied by 1, and 0.8 remains as it is, that it's being multiplied by 1. And then the entirety of this value gets divided by the total number of individuals that are participating in this sprint, that is of 20. So if we were to solve it, 0.77 multiplied by 4 becomes 3, 0.76 multiplied by 3 becomes 2.28, 0.77 multiplied by 5 becomes 3.85, I think. Um, I'm sure it becomes that. Then 0.78 multiplied by 6 becomes 4.68, I think, plus 0.79. plus 0.8. The entirety of this gives us a value of 20. So solve for the mean and tell me, is it definitely equivalent to 0.77? Yes or no? After that, draw a line of best fit. Okay, line of best fit. What basically happens in a line of best fit? In the line of best fit, we try to ensure that the number of points above are equivalent to the number of points below. Number of points above are equivalent to the number of points below the line. So the ideal line of best fit would be somewhat um, looking like this. Let's say this is 5 comma 1.1, 6 comma 1.0, 7 comma 0.9, and let's see the rest of the values, right? So this is 8 comma 0 point roughly 77. Let me see the marking scheme. Does it allow the curve of best fit? No, it does not. But there have been many variations. So I'll tell you of one. The best line of best fit is going to be this one. And we have to make sure that we extrapolate this line up till the end. Why is this the best line of best fit? Primarily because there is one point which is on the line, all right, and there are 3 points below the line, these ones, and then there are basically 3 points that are above the line. So that's how it's supposed to work. This is me explaining the concept. All right, so let's move forward. Use your line of best fit from part C. Write down the value of R for H equals 4 hours and H equals 7.5 hours. So if we were to use our line of best fit, it is supposed to give us somewhere around, mm, let's consider using 7.5. This is 7.5. So this is roughly 0.88 for, for 7.5. 0.88. 8, 8. For h equals to 4, this is going to be a little bit tricky because we don't have a line extrapolated. But the good part is that we can do some sort of a prediction, can't we? Just look, at the value of 8, we have somewhere around 0.77. At the value of 7, we have the line looking somewhere around 0.97. Value of 6, we have somewhere around 1.17. At value of 5 would be somewhere around 1.37. And at the value of 4, as we move forward, one value towards the left, two values move towards the right. Zero point 0.2 values move towards the right. So this becomes, at 4, it becomes 1.57, roughly here. And if we were to extrapolate the line, then yes, that definitely makes sense. So do you understand how did I get 1.57 using other lines?
Yeah.
All right, that's good. I can write this as 1.57. I can simply write this as 1.6 as well, but no worries. We are accepting answers up till 1.57. So two decimal places, that works fine. Okay. W equals 24 multiplied by 100 raised to the power of negative r. Alright. Calculate the value of W when r equals 0.77 seconds. Hmm. 0.24 multiplied by 100 is to the power of negative 0.77. So if we were to solve this question, what answer would we get? The answer should be definitely less than 1. 24 multiplied by 100 raised to the power of negative 0.77. I'm getting 0.692. But here's the catch. Correct to two significant figures. Alright? Now we know, now this is where students get it wrong. Either they're going to write 0.692 or they're going to write 0. 0.6 because they don't understand the concept of significant figures. And beware, this is of 3 marks. Inputting that formula is only going to be 1 mark because the formula is given here in front of you. You don't have to derive anything. You have to substitute the value of r as it is. There's no rocket science. The entire 3 marks revolves around inputting the correct value of r into the right equation and also writing it down to the correct significant figures. So, two significant figures, it would be an answer of 0.69, right?
Yes.
That's how we solve it. All right. Okay, 7 part F. It says explore the probability of winning a race for sprinters with different sleeping habits. In your answer, you identify two relevant factors affecting the probability of winning. All right. So H is basically, as I understand, H is the number of hours slept. All right. W is the probability of winning the race, and R is mean reaction time in seconds. Okay. So in the case where H equals to 4, we calculated above, when H equals 4, R equals 1.57, right? So let's try to substitute it for the first value. 24 multiplied by 100 minus raised to the power of minus 1.57. If we were to solve this part, we would get an answer of 0.017 for the probability of winning the race. 0.017. And when the value of H is 7.5, what was the value of R that we calculated above? 0.88. Sure. Okay, 0.88. So let's substitute the value of R in this equation. 24 into 100 raised to the power of negative 0.88. This becomes 0.417. And we have the value of R as 0.77. So when we had the value for R as 0.77, what value did we calculate for W? 0.69. For the time being, let's just write it down as 0.692. It does not make much of a difference. You see, what's the focus? It says calculate the probability of winning for sprinters with different sleeping habits. Comment on the relationship between the probability of winning and sleeping habits. Justify the accuracy of your findings. Now, there is a lot of things that we have to do. First things first, two relevant factors. The first factor that we have to have a look at is the hours of sleep and mean reaction time, because these two are the core important things that determine the winning probability, right? These two things determine the probability of winning the most. So we are done with the calculation part. Okay. Comment on the relationship. Now, if you were to have a look, H represents the sleeping time, just for the information. If you were to have a look at it, the more that these uh, players sleep, we can see that the chances and the probability of them winning the race is significantly increasing, right? We can see that the more the players sleep, this is our basically comment, the longer the sprinters sleep, the lesser their reaction time. We have to consider the idea of reaction time as well, and more is their probability of winning the race. That is our comment, and that is going to earn us the mark here. All right. Then what do we have? Justification to the accurate justify the accuracy of your finding. So looking at this graph, it's not difficult for us to justify. If we just like how I extrapolated the graph to h equals to 4 hours. Now have a look. What does justification mean? Think about it. This is what IB basically demands here. Um, Initially, when I made the line of best fit, we had to extremely extrapolate the graph to find the value of h equals 4, right? In order to find the reaction time at h equals 4, we had to make our line very longer and we had to do a lot of calculations, right? Isn't it?
Yeah.
Okay. Why is that so? Why did we have to do so many calculations? Because in a real world scenario, it is highly unlikely that an athlete rests for just 4 hours a day. It is highly unlikely that an athlete that needs a lot of rest for his or her muscles to function efficiently, they take a rest of only 4 hours. That's why when it says justify, justification is not just done using the values that are given to you in the diagram. Justification is also done with real life situations. So you can say